Hello friends, my name is Jai Kumar and I'm happy to come back and upload videos. So last few days I got a few good subscribers who keep insisting me to post videos on this. So I'm very happy to be here again and I will keep posting videos from now. So let us understand one of the very beautiful questions of group theory and which is more useful in many places, where P is the smallest prime dividing the group of like the group order smallest prime. For example, anything like mingle with 2 like that. Okay, index to subgroup is always normal. No such things. Okay? But a little more general. Any subgroup of having index P is normal. Okay? So I'm preparing this video really for the next video. Next video is just using group the class equation and simple group action idea. Group of order 15 can be proved abelian, which is little heavier than or little time consuming to understand without using Silos theorem. One may not use Silos theorem at all, okay? But if you go through this thing with class equation and some simple idea, you can understand that how powerful Silos theorem and you can appreciate the Silos theorem, okay? For that only I am preparing this. Okay, let us understand them. There is a very nice collection of video I already uploaded about group actions. It's there. You can go and check out this. I will give the link in the description. Okay, let us understand that. I take such a h. Okay, let's take such a h with the thing, and you know that it's greater than or equal to h is a definitely proper subgroup, and I wanted to prove this is actually a normal thing. Okay, so this symbol we use for normal. And now let's take this space. Now I'm acting G on this. If you see those videos of mine, it will be easy to understand all this. It's a left coset action, and whenever there is an action, automatically there is a permutation representation associated to that. There is a homomorphism from this to this. Okay, whenever G acts on H and there is a permutation representation, that's a group homomorphism from here to X, where Fx is actually set of all bijection map from X to X. Okay. So now G is like this. So G going from this one to this one, and this is a group homomorphism. Let K be the kernel of P. It is a normal subgroup. And by first isomorphism theorem or fundamental theorem of homomorphism, G quotient by the kernel isomorphic to image, right? So image is some subgroup. So using Lagrange's theorem, one can see that this order of this is actually dividing this, right? Right. But let us little bit understand. If you know the general theory, it is easier to understand that how the permutation representations are defined. That means for each G, I have to give you something here which is a bijection, right? So in that way, each G is 5G of AH and GAH. This is how it's defined. So let us focus on the kernel. Whenever there is a G, phi G of ID of X, that means it's identity map on the X, G by H. That takes when G acting on AH, it does not do anything. It just takes AH to the AH. It's not moving at all. In particular, when you choose identity, GH equal to GH, which is H itself, because of this belongs to the kernel. Okay? When I'm taking the kernel, that implies K. The kernel is actually sitting inside H itself. Now that's the one part. Still, we haven't used anything about the minimality assumption we have taken. Now we are going to use. Now take G by K and order of G, which is dividing order of G by fundamental theorem or whatever. The Lagrange theorem one can use. Now, this is the index theorem, right? When you have like this, the total thing. When you have this is the total thing. And now, I don't know this, but I know this. This is P, and let's say this is M. I don't know this, but I know this. M. So that P by M, using this idea, it's a subgroup, okay, some subgroup. Using this idea, we can see that the P factorial, okay, Pm divides P factorial, and take the P out. That means M divides this, and you can see that any prime dividing m should be a prime factor of this. But you can see that prime factors of this are clearly less than p. Clearly less than p. Okay. So clearly less than p. So that means there is no other choice. There cannot be a prime involving in m, and also m is dividing this as the smallest thing. We can say that m must be 1. If some prime factor involved here, some prime factor involved here, that will be smaller than p, then it will be a problem to the assumption. So m must be 1, right? M must be 1. And all the divisors of p minus 1 is also less than. That's what I said. And m equal to 1, that implies this portion is actually 1. It is g by k. So this is identical. Otherwise it won't. This must be equal. So that means k equal to h. And being a kernel, k is a normal. So is h. So this is dead. Again, let me remind you why I am doing this question. I wanted to use this idea to prove about a few things which will be helpful in later understanding the subject also. So I wanted to prove the group of order 15 is always abelian. Okay, just using class equation. We use the beautiful theorems, consequences of Seiler's theorem, which is very immediate. But I like to do still in order to appreciate how powerful Seiler's theorem was. Okay, just wanted to tribute those things. Okay, thank you. Keep supporting, keep watching, keep forwarding this. Thank you.